So let's do this together. I think what I'd like to do is create the point class, the cluster class with some empty methods, and then sort of write a little bit of the pseudocode for our filter, and then you can take it from there. Before we do that, I want you to get your test images into the project. So you should have downloaded a zip called clusteringtestimages.zip. You'll unzip it so you can say extract all. Doesn't matter where you extract them. I guess I've already extracted it here. And then I think probably the best thing to do is select all of your test images and just drag them into the images.bw package in your package explorer, and it will ask how would you like to import them, and you can say copy files, and that will copy them all into that folder. Alright, so I have opened up a test black and white image filter, which I'm now going to copy, because I want to start with a working one. So I'll Control-C and Control-V, and I'll call this clustering. And I'll open clustering. Okay, so let's make some changes. I know that in addition to an output image, we will actually make an output image which colors each of the clusters a different color so that we can kind of visually see what the output is. But as I said before, what we really care about is the data representation. We really want a list of cluster objects. So let's create an array list of cluster objects, which I'll call clusters. You got to import array list. Obviously, we haven't made a cluster class yet, so that's a compile time error. And then right here at the top of filter, let's say clusters equals new array list of cluster objects. Oops. All right, cool. So let's go ahead. Why doesn't it like clusters? Oh, it probably just doesn't know about this yet. Okay, so let's go ahead and make our cluster class. I'm going to make this in the filters package, which is maybe a questionable choice, but there you have it. So cluster, and let's think about what did we say we wanted our clusters to have. We'd said that we wanted a point object for the center of the cluster and an array list of points for all the points assigned to the cluster. So let's do that. I'll make some private fields. Oops. So private private point object, which will be the center, and then private array list of point objects, which will be the points. Let's make a constructor. Let's see, do I want my constructor to take parameters? Let's make a version where you tell the cluster where you want to construct it. So I'll make an int row and an int column. Let's go ahead and make a point class as well. And here I'll make a row and a column. And then I'm just going to auto-generate everything I want. So I'll auto-generate my constructor, and I will auto-generate my getters and setters, and I want a toString where I'll return row, comma, column, and I want to make an equals method, which will let me compare 2 points. So I'm going to compare myself to a point that I'm calling other, and I'm going to return true if this dot getRow equals other dot getRow, and if this dot getColumn equals other dot getColumn. So if my row and column equals their row and column, then I want to return true, otherwise false. All right, so that's my point object. Back in cluster, let's import array list. I've got to, of course, initialize the array list. Oops, points equals new array list, point. And then for my center, I'll make a new point object with the input row and column. All right, great. So let's add all the methods that we said we wanted. I think we wanted a couple of getters. So get center will just return this dot center. get points will return this dot points. We wanted at least 3 more. We wanted an add point, which I'll let you do, and we wanted a recalculate center. This deserves a comment. So recalculate, calculate this dot center as the mean row column coordinates of the points list. Okay, and you do this. And then also we wanted a toString method, which I will also let you do. Okay, cool. So that's our cluster object. Last but not least, let's do a little bit of pseudocode inside our clustering filter. So let's see, we've already made an array list of clusters. Here we're setting up, here we're getting the black and white image, we're getting the width and the height. We want our output image not to be black and white. Our output image is going to be a color image, so I'm going to delete this. And I'm going to comment this out. And I'm going to delete the stuff in the middle because this is doing what the old filter was doing and I don't care about it. So I'm going to call this k-means. This will be my k-means section. This will be display output after that. All right, so let's go visit the algorithm. So let's see, I need to initialize k points at random that represent the cluster centers. So I'm going to actually initialize k clusters and assign the centers to be random. Then I'm going to loop over all the pixels in my image, and then I'm going to calculate for each pixel which cluster's center is closest, and I'm going to add that to the clusters list. All right, let's do it. So, actually, I guess we need to ask how many clusters, right? So I'm going to say int k equals integer.parseInt, j option pane, show input dialog, how many clusters defined. All right, so now that I've got k, you're going to initialize k cluster objects and set the centers to be random. So specifically, you're going to loop k times. Inside the loop, you'll create a new cluster object with random row column, and then you're going to add that cluster object to the clusters list. All right, so that step is done. Okay, for step 2, we're going to loop over all pixels and find the closest cluster to assign them to. So looping over all pixels will loop over all the rows and columns. Let's see, rows are like height. Row plus plus, okay. And now for int column equals 0, column is less than width, call plus plus. All right, and now what did I want to do? Well, I don't want to assign all the pixels to a cluster. I only want to assign pixels that are white. So instead of assigning just white pixels, I'm going to have a threshold. So if, what's my array called? IM. So if IM at row, well, let's do this. Let's say int val equals IM row call. So if val is greater than 200, if val is close to white, then I want to figure out which cluster is closest. Well, this sounds like a great job for a helper method. I want to find closest cluster. What does this method need as an input in order to do its job? Well, it needs to have the clusters list, because I got to loop over all the clusters to find the closest one. And it's got to know what's the point we're at right now. So I'm going to pass the row and the column. And what do I want this to give me as an output? I probably want it to just give me the actual cluster object that's closest. So I'm going to return a cluster. All right, so now you've got a nice helper method there. So now that we've got the closest cluster, we just want to add our point. So closest dot add point, new point, row column. So we're making a new point object for the point that we want to add, and we're adding it to the cluster. All right, great. So at the end of this, we have now done our initial assignment of all the points of interest to our clusters. The next step was to recalculate the cluster centers. So loop over all clusters, have each one recalculate its own center. That'll be step 3. This is step 2. And then I said we want to repeat steps 2 and 3 over and over and over again until eventually the centers don't move. I think as an intermediate step, let's do this. Let's just loop a certain number of times. Iterations equals 0, iterations is less than 10, iterations plus plus. All right, I've got a lot of magic numbers here. The reason I'm doing this is because this is a very straightforward way of seeing whether or not your algorithm is doing something sensible. We're going to run it 10 times. You can take a look at the output, see if it seems to be working. Actually writing the while loop that will loop until none of your centers have moved, that's kind of a complex piece of code to write, and it's very likely it will be buggy. So I want to do this first so that we can just make sure, is this stuff working, and then once that's working, you can come back and do whatever you want to do with it. All right, let's set up the output. So I said we wanted to be a color output. So as you recall from your recent color filters, we're going to need 4 separate short arrays. So we'll make an array for the red values, new short, height, width. And I'm going to copy this and make one for green, blue, and alpha. Great. And now let's see, what do you want to do? So at this point in the code, we're assuming that we have already assigned all of the pixels to the right clusters. So what we want to do is now loop through all the points of every cluster and color exactly those points in our output image. So I think what I want to do is loop over each cluster. And then for each cluster, I want to make a random RGB color. And then I want to loop over all points in that cluster. And I want to assign R to the red array at the points location. And same thing. I'm going to assign the green value to the green array at the points location. And I'm going to assign the blue to the blue array at the points location. And I'm going to assign, you know what, I just want the whole thing to be opaque. So let's assign, I forget whether 0 is opaque or transparent. So assign either 0 or 255 to the alpha at that same place. So you could either look up which one you want to do, or just try both, and whichever one works is the one that works. All right, so that's it. Let's see. We're looping over all the clusters. We're making color. We're looping all the points in that cluster. We're assigning the random color values to the right spot for every point. Great. So that should color each image, or rather, it should color each cluster in the image. And then as the last step, instead of saying set black white image, we want to set, what was it? Set colors, right? So we're going to set red and green and blue and alpha. And that's it. All right, so I think you're all set up to go. So for homework tonight, you should finish the cluster class, and if you want to, you can start trying to write this find closest